Now let's talk about energy. Energy is just the ability to do work. When something has the ability to do work, when it has energy. So there are different kind of energy. We have mechanical, we have chemical, we have nuclear energy, and we have a lot of energy. But in physics, we are going to be talking about mechanical energy, and mechanical energy is divided into two. Mechanical energy. Mechanical energy is it can be classified into potential energy and kinetic energy. You should know that. So potential energy and kinetic energy. Potential energy is just energy due to position of a body. So let's say we have a ball here, and it's just situated at this particular height. It has the potential of doing energy because when it falls down, let's say a glass is here and it falls down on this glass, if you shatter the glass, that's don't work. So it has the potential of doing energy. And kinetic energy is just due to motion. You should also know the formula for potential energy and kinetic energy. So for potential energy, the formula is mgh. The formula is mgh, and for kinetic energy, the formula is half mv squared. Half mv squared. So this is the formula for potential energy, and this is the formula for kinetic energy. Now let's talk about the work energy theorem. The work energy theorem. So let's talk about the work energy theorem. What work energy theorem is just trying to tell us is that work done, work done is also equal to change in kinetic energy. That's what work energy theorem is trying to tell us, that work done is equal to change in kinetic energy. So if they ask us to find work done and they give us value for kinetic energy, it must be change in kinetic energy. And change in kinetic energy is kinetic energy final minus kinetic energy initial. Minus kinetic energy initial. So it must be change. It must be a change in kinetic energy, not just kinetic energy. Change in kinetic energy. And work done is equal to change in kinetic energy. So let's solve questions on work energy theorem so we can understand it better. So this is the questions. This is the question here, and it is available in the description below this video. There's a link there to download it. So just download it through the link so you can follow. So they said, okay, so let's solve questions. Let's solve questions on kinetic energy and work energy theory. So, right, okay. Let's look at question number one. They said a 0.6 kilogram, that's mass is 0.6 kg, has a speed of 2 meter per second. That's 2 meter per second at point A, and it has kinetic energy at point A, and it has kinetic energy of 7.5 joule at point B. So the kinetic energy at point B is 7.5 joule. That means from this question, that means you can see that the object was moving from point A to point B. The kinetic energy of point A, we don't know that. The kinetic energy of point B is what we were given in the question, which is 7.5 joule. Then the question now said, what is its kinetic energy at A? At point A, what is the kinetic energy? So let's solve for that. So you all know that kinetic energy is half mv squared. So from that, you can just, so kinetic energy of A is equal to half mv squared. That will give you half times m, which is 0.6, times v squared. That's 2 squared. That's 2 squared. That's 4. So when we solve this, what we get is 0.3 times 4. That's 1.2. That 1.2 joule. So the kinetic energy at point A is 1.2 joule. 1.2 joules. So we've gotten that kinetic energy of A is 1.2 joules. Now they're not asking us, the question B now say the total work done on the particle as it moves from, okay, B, that's not question B, that's question C rather. So question B now said, what is its speed at B? So that's just easy. The kinetic energy at B is 7.5, and we know kinetic energy is half mv squared, right? So they are now asking us what's the speed at point B. Kinetic energy is 7.5 joule is equal to half. We all know that mass is constant, mass does not change because it's the same object, so mass is constant. So there's nothing like mass 1 and mass 2, is all the same subject, so mass is constant. So our mass will still be 0.6, so times v squared. So they're asking us to find velocity. That's v squared is, we just multiply 7.5 times 2, which is 15, and 15 divided by 0.6, that's 25. So square root of 25, let me take the square root of both sides. Square root of 25 will be 5. So that's 5 meter per second. So that's the answer to, question B. Now question C. Question C now says, what is the total work done on the particle as it moves from A to B? So what is the total work done? So from work energy theorem, we know that total work done is change in kinetic energy. Change in kinetic energy. Total work done is change in kinetic energy. So from this information is very easy. That's kinetic energy final minus kinetic energy initial. In this question, our final is B because it moves from point A to B. So it should be kinetic energy B minus kinetic energy A. That's 7.5 minus 1.2. So let me write it for proper understanding. So that's kinetic energy B minus kinetic energy A. Can you see the board? So that will be 7.5 minus 1.2. So our work done will be 6.3 joules. So that's the final answer. Our work done will be 6.3 joules. So that's how to solve question like this. Let's take another question. So let's take this second question. They said a 0.6 kilogram, sorry, second question, a 3 kilogram object. That's 3 kilogram object. The mass is 3 kg. It has the velocity of 6I minus 2G. So our velocity is 6I minus 2G meter per second, right? So question A now say, what is its kinetic energy at this time? Question B said, find the total work done on the object if its velocity changes to. So let's first answer question A. What is its kinetic energy at this time? What's formula for kinetic energy? Kinetic energy is half mv squared. But looking at this our velocity is not given a value. Like, it's just given in unit vector, not in a specific magnitude. It's just given in unit vector. So how do we like convert it into a definite value? How do we find the magnitude? So to find the magnitude, it's very easy. I've taught you. So that will just be, to find the magnitude will be the square root of the squared. Yeah, that's 6 squared plus 2 squared. So that'll be 2, that'll be root 40. But we need to find the definite value. That'll be at 6.32. That'll be 6.32 meter per second. 6.32 meter per second. So we just have to impute our velocity here. But there's this, let me first continue. So that's half times 3 times 6.32 squared. That'll be half times 3 times 40. That'll give you 60 joule. And our kinetic energy at VA, our kinetic energy, okay, at that time is 60 joule. But there's this fast way of doing it. Instead of looking for the square root, then taking the square again. You know, when you find the square root of this, you got 6.32. When we take the square, it's going to give this value. So instead of just like wasting time, when you find the square root, when you find the magnitude of this stuff, root of anything you get, just put it that way. I don't think you understand, because when we did the square root of this stuff, we had 6.32. Like when we did the magnitude, we had 6 squared plus 2 squared, we had 6.32. But in kinetic energy formula, it is v squared. So we still have to square this stuff, and it's still going to give us root 40. It's still going to give us root 40. Like it's still going to give us the magnitude back. So instead of just doing that, you can just do that fast way, or don't bother, just square root it, then square it again, you get the same answer. But that one is just to make it fast. But if you don't understand the short process, just do it the way you understand and get your full mark. So your brain will not be racked. So question B now said, find the total work done on the object if its velocity changes to. So our work, the kinetic energy that we got was 60 joule, right? That's the one we got. So question B now said, find the total work done on the object if its velocity changes to, and its velocity changes to 8I plus 4J meter per second. So they're asking us to find the total work done. To find the total work done, we know total work done is change the kinetic energy. We already know the kinetic energy of the initial. What's the kinetic energy of the final? Formula for kinetic energy is half mv squared. Half mv squared. So how do we input our value? We already know that mass is constant. So mass is 3 kg. That's half times 3 times. We look for the magnitude of this v squared. So let me just use that one to explain what I was saying earlier. Instead of doing the square root and doing the square, let me just explain what I was saying earlier. So let's find the magnitude of v. Of course, we have to find the magnitude of v because here is given a unit vector, not in a definite value. So we need to find the magnitude. So that will be the square root of 8 squared plus 4 squared. So the square root of 8 squared plus 4 squared, that's square root of 8 squared plus 4 squared. That will give you 2 root 6, right? That's 2 root 6. Or let's say 8 squared plus 4 squared. That was 80. Let's say root 80. My calculator is like simplifying it. So let's say root 80. Root 80. Let's say this is root 80, right? Because 8 squared plus 4 squared is root 80. But instead of now looking for the square root of this 80, then putting it back, then taking the square again, we can just write 80. So you see what I'm saying? That's 80 times 3 divided by 2. That's 120 joule, right? That's 120 joule. That's 120 joule, right? So let me now explain what I've been saying. Let's say we don't know how to put 80. Let me do it the way it's supposed to be done, not the fast way. So let's say root 80. What's root 80 now? Root 80 is 8.944. That velocity is 8.944 meter per second, right? So input it back. That's v squared. That's 8.944 squared. So when you do 8.944 squared, well, it was 8.944 squared. 8.944 squared will give you 79.9, which is still 80. Approximately 80, still 80. So that's 80. So you can see it still give us back 80. So instead of doing the square root, if you're looking for magnitude, you have to do the square root of this. Since it's kinetic energy and the square is still going to be there, you can just say, in the exam you need to be very fast. So instead of doing that, you can just say square root in kinetic energy is half mv square, right? So just write half times what's m? M is 3 kg. What's our velocity? From here, just do it. 8 squared plus 4 squared. That's our velocity. That's 80. Like just 8 squared plus 4 squared at 80. Then you find the answer. This will be 120 joule. So this is very fast. Instead of looking for the magnitude first, and after looking for the magnitude, you now square it. That's the normal process, but it is slow in the exam hall. So in the exam hall, just write half m, write your m times v squared. Now just take it 8 squared plus 4 squared. Anything that is here, just square everything and just put it inside. You get the same answer and it will be correct. You can try it for other questions you will solve or you are going to solve on your own. You see that it's still the same thing because it's just normal logic. So now let's check question 3 under kinetic energy. They said a 12 Newton force, a 12 Newton force with a fixed orientation does work on a particle and moves through the three-dimensional displacement of the displacement is 2i minus 4j, 2i minus 4j plus 3k, 2i minus 4j plus 3k in meter. So they now ask what is the angle between the force and the displacement if the change in the particle's kinetic energy, the change in the kinetic energy is 30 joule. So this question is just testing your knowledge on work energy theorem and testing your knowledge on how to find the angle between force and displacement. So it just depends on you on how to quickly remember formulas and connect it together and find your answer. So they gave us kinetic change in kinetic energy to be 30 joule and they're asking us to find the angle between force and displacement. But we all know that work done is change in kinetic energy. That means change in kinetic energy is also work done. So this can change in kinetic energy they gave us to be 30 joule is also saying work done is 30 joule. So we can just change this and write work done is 30 joule. And from the formula I gave you, I said W is equal to Fs cos theta. We have to find this theta because this theta is the angle between the F and S. So what's work? Work is 30 already. That's 30 joule. F, the magnitude of F is already given as a definite value, so it's 12. That's 12 times the magnitude of this displacement. It is given unit vector. You have to find the magnitude to get a definite value. So that will be the square root of 2 squared, square root of 2 squared plus 4 squared plus 3 squared. That will give us 5.39. That's 5.39 cos theta. So let's find theta. Now theta will be cos inverse of 30 30 divided by 12 times 5.39. 12 times 5.39. Now theta will be, let me look for that. 30 divided by 12 times 5.39. That will give you 62.37 degrees. 62.37 degrees. And that's theta. That's theta right there. So that's how to solve question like that. Now let's talk about power. Power is very easy to understand. Power is just the rate of doing work. And when we say rate of anything, we are like comparing that thing to time. So when you say rate of doing work, that's the rate at which work is done. That's work relating work with time. So power is rate at which work is done, and the formula is power is equal to work over time. Power is work over time. You should also know that power is force times velocity. Force times velocity, and power is a scalar quantity. So this force times velocity is F dot V. So since power is a scalar product, then F dot V has to be, we have to use, since power is a scalar quantity, F dot V has to be a scalar product. So we use F dot V. And it can also be written as power is equal to FV cos theta. As far as it's still scalar product, as far as it's still scalar product, it can be FV cos theta. So power can also be FV cos theta. Power can also be, power is work over time. This is what you should know. That power is also work over time. Power is F dot V. Power is FV cos theta. Just write it down. Write those formulas down. You also know power is, since work done is change in kinetic energy, power is also change in kinetic energy over time. Since work done is change in kinetic energy according to work energy theory, so power can be kinetic energy, change in kinetic energy over time, I know kinetic energy is half mv squared. So divided by t times 1 over t. That will give us mv squared over 2t. So this is also another formula for power. But you don't even need to know all this formula. You don't need to know this formula. Just know that power is work over time, and if work is change in kinetic energy, then change kinetic energy over time. Power is equal to force times velocity of force dot velocity, that's dot product, or F v cos theta. You don't need to know a lot of formulas. Just know the the key one, the one you should know. That's power is equal to work over time. Now let's just solve one question on power. Let's solve one question on power. This question is in the slide. To get access to the question, the link is in the description below. Download it and follow. So the electric motor of a model train accelerates the train from rest to 0.62 meter per second. 0.62 meter per second in 21 millisecond. That's ms, 21 millisecond. Take note of all those prefixes. Millisecond. So that the time is millisecond. That's 21 times 10 raised to power minus 3 seconds. Now said the total mass of the train is 875 grams, right? But our mass has to be in kilograms. So what do we do? Divide by 1000. That will be 0.8 0.875 kilogram after dividing by 1000. And now say we should find the average power delivered to the train during the acceleration. Find the power. So from what I've discussed, they gave us velocity, they gave us mass, they gave us time. If you know where, if like from the formulas you should know that you've known, that you've written down and know, you should know that power is equal to work over time, and work is change in kinetic energy. They've given us mass and they've given us velocity. What should come to your mind is kinetic energy. If you already know the formula as half mv squared, the formula that should come to your mind, that even has come to your mind, is half mv squared. And time is given. That's power is change in kinetic energy over time, right? And change kinetic energy is half mv squared. So let's find half mv squared. That's half times mass. Mass is 0.875 times velocity 0.62 squared. That will give us, let's calculate that. That will be times 0.875 times 0. That will give us 0.17. Let's say 0.168. 0.168 joules, right? But power is change kinetic energy over time. So we have to divide this stuff over time. That's divided by what we have here. 21 times 10 raised to power minus 3. 21 times 10 raised to power minus. Yes, so after dividing by this, so what you get is 8. That will be 8 watts. That's 8 watts. So this is the final answer, 8 watts. So that was all on work, energy, and power, and work energy theorem. Thank you. If you reached the part of this video, make sure you like, make sure you share, and make sure you subscribe to Schematic series. Thank you.